Hey everybody, it's Bob Crossan, Senior Managing Editor for Water and Waste Digest. I'm here today with Nate Warren. He is Senior Sales Engineer for Xylem. So, Nate, we were going to talk about this project that you had in Los Angeles with some bypass pumps. It looked like a pretty interesting one, pretty deep wells, and some challenges involved there. So, why don't we just kind of start? Let's set the stage. Could you give just a high level? What's this project about?
Yeah, so there was a sewer line that is in a very, very old part of downtown Los Angeles, and it had collapsed.
Hmm.
And when it collapsed, it created a void in the sewer, and in some cases, that void was actually about 30 foot in diameter over the top of the sewer.
Holy cow.
It was a pretty dangerous situation. There's large transmission structures which carry high voltage power lines. And one in particular was right over the top of that void.
Oh
And
my.
uh, and so that was if that void got any worse, the sewer line or the transmission structure could actually fall over.
Hmm.
And then when it would fall, those power lines could possibly get dropped over the top of the 110 freeway, which is a integral highway that connects the San Fernando Valley and downtown LA. So that was pretty dangerous. Also, there one of the things that we really haven't talked about too much was there was some freight train, a railroad track that was right
Oh.
there also. And so there was just a lot of possibilities that this thing could collapse.
Hmm.
And so it was an emergency that we had to bypass this sewer line so that construction crews can get in and take care of the sewer.
Hmm. Yeah. So you mentioned a lot of like the infrastructure that you had to work around there. One of the things I think that was also mentioned is that just kind of the depths of things weren't accurate in what was given to you guys initially. I think it was like an extra, like, what was it, almost 20 feet difference between the depth, right?
Yeah, yeah, and that was pretty surprising. Um, the sewer line being so old, some of the records just weren't very accurate, and so what we were all under the impression that it was about a 35-foot deep sewer.
Hmm.
And once they started really digging in and to understand this particular stretch of sewer line, it ended up being 51 feet deep.
Oh my gosh.
And so that was a big number there.
Hmm. So how did that specifically change the ways that you had to approach the project? Were there certain aspects that you had to like kind of adjust on the fly for that?
Absolutely. I mean, you know, this being just a real congested part of LA,
Hmm.
um, we had to look at what our footprint would be for the bypass system. So that was number one. Is like, where are we going to put, you know, 5 or 6 pumps?
Yeah.
And then once the depth of the sewer line was understood, is like, well, we got to kind of start from scratch here. We have to
Hmm.
understand this. And so we went with the submersible option because automatic self-priming pumps, they can't prime or even run effectively
Hmm.
um, at, uh, at 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 that level. 51 feet or even 35 feet really couldn't. You would have to bring the sewer level up so high to get the
Hmm.
water to those pumps,
Yeah.
um, and that just wasn't achievable with this system.
Hmm. Yeah, just like the feet of head that you'd have to work with because of that change makes a huge difference, right?
Yeah, yeah, and remember, we're still dealing with an old sewer line here, so even if you could raise that sewer level up past the top of the pipe,
Hmm.
you're really putting that sewer line at risk because it's so old. And
Yeah.
the extra water pressure and some other factors came into play, and it just wasn't even doable. So we really had to design a bypass system that was going to keep that water level below the top of the pipe, and that
Mhm.
way it reduced the chances of that sewer line collapsing further.
Yeah, yeah. Well, yeah, and like then it's just you have that, and that's added on top of the complication of the other
Mhm.
utilities and stuff running
Yeah.
through the area,
Oh
right?
yeah. Oh yeah. And there was other utilities that had to be dealt with in order to dig that structure that we ended up putting the pumps that we had to put the pumps in. So some utilities had to be rerouted
Mhm.
and dealt with. And you know, again, being in this old part of LA, some of these abandoned lines and electrical lines and things just weren't really
Mhm.
known. And so it
Mhm.
wasn't until they started digging they started understanding what was there.
Yeah, yeah. Well, yeah, and that's interesting too, because I feel like a lot of projects, I always place an emphasis on the difficulty of a project around just how many stakeholders you have to work with, right? So not only are
Yeah.
you working with the public, you're working with the local utilities there, but not only the sewer utility, but like the electric utility and the cable utility and like all those other ones. I feel like the more of that that's added on, the complexity of the project just increases astronomically. Am I right in that assumption?
Yeah, yeah. I mean, and abs 100%. And one of the other things we had to deal with was traffic.
Oh,
And
good one. Yeah.
yeah, yeah. And because we had to run the discharge lines down the center of a street, well,
Mhm.
how are you going to do that and impact the traffic?
Mhm.
Fortunately, the street that we did use had 4 lanes of traffic, two in each direction, and so we were able to use that to our advantage. But still,
Mhm.
this was a major street that got busy in the morning when everybody's going to work, and then in the evening when everybody's leaving.
Mhm.
So that had to be dealt with,
Mhm.
and so there was just a lot of moving pieces.
Yeah. Well, and especially traffic in LA, right?
Yeah, yeah, it's absolutely nuts. Yeah.
Yeah, so what were some of the measures, that you guys took for safety? Obviously, this thing's, pretty deep underground, and there's generally a lot of, like, requirements, and regulations around that kinda stuff, so what were some of the things that you made sure to keep in mind when you were doing this project?
Well, safety for Xylem is huge. And then the contractor that we were working with, Artukovich, they were really, really great about keeping the site safe and secure.
Mhm.
So when you're dealing with a pit. At the end of the day, the pit was about 40 feet deep because
Okay.
the contractor did have to level the pad a little bit, so he cut it down about 10 feet or so. And so then you're dealing with a pit that's 40 feet deep with rushing sewage underneath it and pumps that are running. You don't want to fall into that. So
Mm.
they're really good. They built a what do you want to call it, handrail
Mm.
around the wet well. And then anytime that we had to go over that handrail for whatever reason, all of our guys had safety equipment on
Mhm.
and to keep from falling in. So that was a big concern for us.
Yeah. So now, what's the status of the project now? How are things at this time?
Well, the bypass is done. So, it ran for about 7 months.
Mhm.
And so the bypass system is done. We've pulled it all off site. There's another phase because this sewer
Mhm.
line is got a lot more work to do before it's before it's repaired.
As many
So
sewer
there,
lines do.
yeah, yeah, yeah. So there's another phase that's coming out, and this phase is actually upstream
Mhm.
of where we were at because there's another collapse and another void upstream.
Gotcha.
So it's still being dealt with.
Yeah. So I imagine you guys are you'll end up working with that one then too, and probably a lot of lessons learned from this one can apply there.
I hope so. Yeah, yeah. I mean, we're definitely going to use the lessons learned, and we would really really like to get that next phase. So
Yeah.
something we're
So
working
on
on.
yeah, and I mean just on those lessons, what was kind of your biggest lesson that you learned from this one? What was your biggest takeaway from doing this project?
The biggest takeaway for me was this was a real, and we knew this coming in. This was a real rag heavy line. There was a
Okay.
lot of debris, and and the city was very clear with us on that. And the contractor understood it. We understood it. And so we went into this project really with some unknowns. It's like, how are we going to, um, you know, react, and how are we going to uh, be able to safely pull a pump if it does get ragged up?
Mhm.
And so we went into this with some really great technology that allowed us to have like clog detection on the pumps and other things. And so for the next phase, we're really going to make sure that we use that. We're going to make sure that we have our non-clog technology available, our clog
Mhm.
detection system installed, so that we can address any potential clogs that come up. And because that's a real thing. It's real in permanent pumps. It's real in
Mhm.
bypass pumping. We have to be prepared for potential rags.
Yeah, that's a really interesting conundrum for a project like that. I hadn't even thought of that until you mentioned it, but obviously rags are like such a big deal, even just in normal day-to-day utility life. So why wouldn't they be something that you'd have to deal with in a situation like
Mhm.
this too? So.
Absolutely, yeah, yeah. One of the things one of our many success stories off this last project was that clog detection.
Hmm.
And because we were able to detect when a pump was actually starting to to rag up, we were able to address it quick, and we were
Hmm.
able to address it before we even had to pull a pump.
Oh
Because
wow. Okay.
the last thing we wanted to do was pull in this last case. Those pumps weighed over 10,000 pounds apiece, they're 40 feet deep, and we wanted to avoid, if at all possible, pulling one of those pumps.
Hmm.
And so we used the software in our remote monitoring panel that measured amps, and it also measured it against the total flow that pump was performing at.
Hmm.
And so when we start seeing amps rise and flow lower, or flow reduce on the pump, we knew that that pump was having problems, and so we addressed it right then and there. We used backflow. We used a back flush valve, and what it
Okay.
did is you turn the pump off, and you would open this valve. It would let air into the system. It would pull the rags out of the pump. You'd close it, turn the pump back on, and it would off it went and start pumping as good as new. So we were able to really address that, and that really saves so much time and effort, and also money for the whole project to be able to,
Hmm.
to have to derag one of those pumps
Yeah.
and deal with that.
Yeah, well, that would use also fewer pumps, so if you had to take one offline, you don't have to have others on hand in the event of that kind of thing, or you can have fewer
Exactly.
on hand, basically. So,
Exactly. Yeah. Yeah.
yeah. Cool. Well, thank you so much for your time. I appreciate it. Is there anything else you wanted to touch on with this project?
Just a great team of the contractor, Vito Artukovic and Sons. They were awesome to work with. The city of LA, they just, they're very supportive. It was a high stress project. It was a high risk project for all, but I think that everybody really came together and really supported each other. And it was nice to see it come to an end. And we're looking forward to hopefully working with everybody in the future. So thank you.
Yeah. Well, thanks so much. We appreciate your time.